Sorry about that. They updated my recording program and I'm having a hard time with the new controls. Anyway, I'm sorry I'm not there today, but you still are going to get a lesson on graphing secant and cosecant functions. I think it's something that you'll be able to understand fairly easily. So you should have these guided notes in front of you that the substitute teacher gave you. So we're going to go through the notes. I apologize if it's messy. I am writing on a touch screen. So I'll just do my best to be as neat as possible. Okay, so today's date is 2/19/20. Okay, so as I said, we're going to be graphing secant and cosecant. Let's remember that the secant is the reciprocal of the cosine. Oh, see, I'm already messing up. Is the reciprocal of the cosine function. So that's the fact that we're going to use to graph it. Now, sometimes the secant doesn't exist, and we found that out through doing our triangles and looking at all of our SOHCAHTOA. Since the secant is the reciprocal of the cosine, it's not going to exist where the cosine is equal to 0 because you can't reciprocate 0. So where is cosine equal to 0? So if we look at the unit circle, the cosine is equal to 0 at pi over 2 and at 3 pi over 2. No, my highlighter's not working. At pi over 2 and 3 pi over 2 and anything coterminal with that. So we know that the secant does not exist at pi over 2. Yes, that's supposed to say pi over 2. 3 pi over 2, etc. Now the cosecant is the reciprocal of the sine. So we know that the cosecant doesn't exist where the sine is equal to 0 because you can't reciprocate 0. So where does the sine equal 0? Well, the sine equals 0 at 0 and pi because the sine is the y value. So at 0, pi, and anything coterminal with that, the cosecant does not exist. Okay, so let's remember what happens with what happens to a graph, or what is created on a graph where the domain of the function does not exist. Does anybody remember? We've dealt with them a lot. They're called asymptotes. So when you have restrictions on your domain, you have asymptotes on your graph. Okay, let's see if I can scroll up here. This seems to be my hardest thing to do here. What happened to my A on asymptotes? Oh, there. Okay. So we're going to go ahead and take a look at the cosecant function. We're going to graph your basic cosecant function, and we're going to graph 2 periods of it. But what we do is we start with the sine function. We're going to graph the sine function, but please remember the sine function is not part of the graph. It's just a means that we use to get to the cosecant graph. So if we remember graphing sine function, the sine function has a period of 2 pi. Okay, and then we look at the 5 key points. We look at the midpoint, which would be pi. We look at the quarter point, which would be pi over 2. And then we look at 3 pi over 2. I should use a thinner pen. All right, and if we remember, the sine function goes as high as 1 and as low as -1. And then we graph our 5 key points. So our 5 key points look like this. Sine starts at the origin, then it goes to its high point, then it goes back to the middle, and then to the low point, and then back to the middle. And this is what the sine wave looks like. And of course, I never hit my points right. So we make bigger dots. Oh, maybe. Not so easy to do on the touch screen. Okay, so second, the next period would end at 4 pi. And then right in the middle, we would have 3 pi. And then, so that's 3 pi over 2, 4 pi over 2. This would be 5 pi over 2. 6 pi over 2. And 7 pi over 2. I can make that better. Give you guys a little time to catch up if I'm going too fast. 7 pi over 2. Okay, and then we make another sine wave. Okay, so that's what the sine wave looks like. So now if we want to graph the cosecant function, you have to remember that every time the sine is 0, the cosecant doesn't exist. So wherever the sine function hits the sinusoidal axis, you have an asymptote. So the sine function hits the sinusoidal axis right there at pi, at 2 pi, at 3 pi, and at 4 pi. Okay, those are very colorful asymptotes. Okay, we create asymptotes. Now, all you do is you reciprocate the functions that you see. So it's an interesting concept, but if I were, I'm going to do this in a different color, blue. They always share a point. The cosecant function and the the cosecant function and the sine function share the turning point. So they share this point right here. And then the graph gets flipped over and they become parabola-looking functions like that. And they do go up forever and ever. Okay? Because when you reciprocate fractions, they become very large numbers. And then here they share this minimum point, if you can see where I'm drawing it, this minimum point. And then, whoops, that's a really ugly one. They make a parabola-looking function. And they go down forever. And then they share this turning point, and they go up forever. And then they share this turning point, and it goes down and it approaches the asymptotes. But it never crosses the asymptotes. Okay? So what you see in those lovely colored functions, the multicolored ones, is the cosecant graph. So it's a really simple concept. You just graph the sine graph. Wherever it crosses the sinusoidal axis, you put asymptotes. And then you actually reciprocate or flip the function over. Now remember, this green sine wave that you see is not part of the graph of the cosecant. So if you like things really neat, you can go ahead and erase, whoops, didn't mean to erase that. You could go ahead and erase the sine wave. And when you erase the sine wave, that's what the cosecant function looks like. Okay, so it looks like a bunch of parabolas. But they're not really parabolas. Okay, they're parabola looking, but remember, parabolas get wider forever. These approach asymptotes, so they look like parabolas, but they are not. Okay, so let's talk about the domain of this function. The domain is actually pretty difficult to write because this function is basically a piecewise function. There's a lot of little pieces. It's broken up. It's a discontinuous function. So the domain of this function is, now the domain is the x-axis. So it's all real numbers. So I'm going to write down here. All real numbers, that's that fancy R, except, again, trying to write with this pen is not helping me. Except, I don't know why sometimes it doesn't write. You can't tell, but I'm pushing on the screen and it's not writing. There we go. And what we're going to write is we're going to write pi k over 2, where k is what? So we have to look at this. Oh, I don't want to write pi k. I just want to write pi k. I'm sorry, not pi k over 2. I want to write pi k. The domain is all real numbers except all the multiples of pi. Okay, so if you look, I'll try to highlight it. Do you see how we have an asymptote here at pi? This got erased. When I erased it, this was 2 pi. We have an asymptote at 2 pi. We have an asymptote at 3 pi, 4 pi. So the domain is everything except those. So we write pi k, where k is equal to an integer. Whoops. Sorry, I don't want to write and highlight. I know that's a little hard to understand. But the domain is all real numbers except for where those asymptotes occur. And those asymptotes are integer multiples of pi. So k could be 1 and you'd have 1 pi. K could be 2 and you have 2 pi. K could be 3, you have 3 pi. And it would also include the negatives that would exist on this other side of the graph, which we're not going to do. So it's all real numbers except pi k. Now, what's the range of the graph? Well, notice the sign went between -1 and 1. The cosecant goes from 1 up and from -1 down. So I can't quite fit it here, so I'm going to write the range over here. The range is -infinity to -1. That's not letting me put it in a comma. Try a different color, see if that works. -infinity, that's an ugly comma, to -1 union with, and then it goes from 1 to infinity. Oh, I'm trying to write the infinity and it's just not letting me. There we go. So it's just the opposite of the sign. The sign range is between -1 and 1. The cosecant range is from -infinity all the way up to -1 and then 1 to infinity. Okay, I'll try to go a little faster next time. Okay, so let's try the cosecant graph. Sorry, secant. It said cosecant. Okay, so just like that, we're going to start with the cosine wave. Okay, so the cosine wave goes from 0 to 2 pi. We'll just draw a basic cosine wave. The quarter point is pi over 2. 3 pi over 2. It goes as high as 1 and as low as -1. And then the cosine wave goes high, middle, low, middle, high. And it looks like that. Now we'll go ahead and make the second period. We'd go to 4 pi. Middle point is 3 pi. Sorry for the messy writing. I'm trying. And the quarter points would be 5 pi over 2 and 7 pi over 2. And we make another cosine wave. Whoops. Okay, so that's the cosine wave. Now remember, that's not part of the graph of the secant. It's just a means to get to the secant graph. So now we need asymptotes. Asymptotes occur every time your graph crosses the sinusoidal axis. So there's an asymptote at pi over 2, 3 pi over 2. Because remember up above, this is where we said it didn't exist. 5 pi over 2. And 7 pi over 2. Okay, now reciprocating this one's a little weird because you have, when you do the asymptotes, you sort of have these half waves. So we did the asymptote. Now they share this high point and we have to flip it over. Now there really is the other part here. Okay, but we're just not graphing that. That's not part of this period of the function. And then they share this point, this low point, and you reciprocate it. And then they share this high point, and you reciprocate it. Low point, reciprocate it. This high point, don't forget these end ones. You sort of have these half parabola-like things on the ends of these. There really is the other part that goes up like this, but that's just not part of this period from 0 to 4 pi. Okay, now again, remember, the cosine wave is not part of it. So if you wanted to erase your cosine wave, you could go through and erase it. And there's your secant wave. Okay, and remember, these half of parabolas are really sort of not part of the two periods we're graphing. Okay, so this is why you see I started to mess up on the domain of the other one. So what's the domain of the secant wave? I didn't leave myself enough room here, so I'm going to write it below. I won't write that. I want a skinny pen. It's all real numbers. Fancy R. Except, this is really the only way to write this. So you're going to put an exception at all of the asymptotes. So this one, you can see my asymptotes are multiples of pi over 2. That's a K. Okay, the asymptotes are all at multiples of pi over 2. They're at 1 pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, where the asymptotes are. So we're going to exclude all the multiples, that's what K means, all the multiples of pi over 2, where K is an odd integer. Where K is an odd integer. You can see, I'm not putting an asymptote at 4 pi over 2. K can't be 4 because 4 pi over 2 would be 2 pi. Okay, and the range, got to pick up the pace here. The range is the same as the range before. It's negative infinity to negative 1 union 1 to infinity. All right, so let's get a little fancy with it now. Let me try to scroll here. Whoops. Okay. So now we're going to add some transformations to the graph. Okay. We want to graph 3 secant 2x plus 1. But to do that, we're going to start with 3 cosine 2x plus 1. We're going to graph that, and then we're going to draw our asymptotes and reciprocate it. Okay, so amplitude. The amplitude is 3. That's the amplitude right there. Okay. B in this case is 2. Okay, B is the number in front of the x. So the period of this graph, you always take 2 pi and you divide it by 2. The period of this graph is pi. So we have to complete a cosine wave in pi units. There is no C, there's no left and right shift, so we start at 0 and we end at pi because the period is pi. This does have a sinusoidal axis change. Okay, we have an upshift of 1, so D is 1, so my new sinusoidal axis is y equals 1. Okay, so right here at y equals 1 is my new sinusoidal axis. It's not very straight, is it? Oh. Okay, we have to complete a cosine wave in pi units. So we need the midpoint would be pi over 2. The midpoint here would be pi over 4. Can't get the other half of my pi on it. There we go. Pi over 4. And this would be 3 pi over 4. Now I've got an amplitude of 3. So this graph is going to go as high as 4. Ooh, I'm going to really run out of space here. And it's going to go as low as negative 2. So I got to go 1, 2, 3. As low as negative 2. And again, if you want to draw in, told you about this, people like to draw these in as their little road maps. And now we need to complete a cosine wave. So cosine starts high. This is now your middle. This is now your low, middle, high. And there's a cosine wave. Okay. Next period is going to end at 2 pi. So halfway in between pi and 2 pi is 3 pi over 2. Halfway here would be 5 pi over 4. That would be 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. This would be 7 pi over 4. Okay. Right, 4 there. Complete another cosine wave. So middle, low, middle, high. Okay, so there's the cosine graph. Now we haven't drawn the secant graph yet. So to draw the secant graph, every time the cosine graph hits the sinusoidal axis, you have an asymptote. So I hit the sinusoidal axis at pi over 4. I hit the sinusoidal axis at 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, then you go to all your high and low points. So I have a high point reciprocated. It's that little half of the parabola-like thing. Low point, flip it over. High point, flip it over. Low point, flip it over. High point, flip it over. Okay, and then if you want, you can delete your cosine wave. And there's your secant graph. Okay, we're going to add one more piece of the puzzle. Oh. Huh. Well, looky there. I messed up on the notes. Okay. So we need to change these because I copied and pasted, but I forgot to change the equation. So we're going to change these equations. We're going to graph y equals negative 1/2 cosecant trying to remember because I did this in class and now I'm at home. Cosecant 2x plus pi plus, minus 1. Okay. So what that means is we're going to start with the same graph, but with sine, because sine is the reciprocal of the cosecant. Okay, so let me get back to my full screen here. Okay, so first thing we're going to do is start with the amplitude. So the amplitude of this graph is 1/2. Okay. The b is 2. So the period is 2 pi over 2, which is pi. So the period is pi. This one does have a c. The c is pi. So this one does have a phase shift. It's a left-right shift. So to find out where this graph starts, you take everything in the parentheses and set it equal to 0. If I solve that for x, I get negative pi over 2. So this graph starts at negative pi over 2. Where does it end? You take 2x plus pi and you set it equal to 2 pi. Okay, solving that for x, you get pi over 2. Okay, so that should make sense. If it starts at negative pi over 2, it'll end at pi over 2 because the period is pi. So it's a whole pi units from negative pi over 2 to pi over 2. Okay, so let's graph this one. So what this means now is my period starts at negative pi over 2. And it ends at pi over 2. Okay? Halfway in between negative pi over 2 and pi over 2 is 0. It should be on the 0. The quarter points would be pi over 4 and negative pi over 4. Okay, again, sorry for the real mess. Okay. Oh, I forgot about our sinusoidal axis. So the D is negative 1, so my sinusoidal axis is y equals negative 1. Okay. You know what? Just for neatness reasons, now that I see what's happening with this graph, I am going to erase these numbers, and I'm going to put them up top. So this would be negative pi over 2, negative pi over 4, 0. So hard to write neat on this. Pi over 4 and pi over 2. Okay, this one's got a downshift of negative 1. So this is my new sinusoidal axis. It's got an amplitude of a half. Now you see why I move my numbers. So it's going to go as high as negative a half and as low as negative 1. Let's go negative 3 halves. Can't even read that. Negative 3 halves. Okay, and if you want to put these lines in here, this is where your graph is going to stay between. I'm going to scroll up a little more here. Okay. Now we have to graph a reflection of a sine wave. So the sine wave starts in the middle. Whoops, that's not where it starts. It starts in the middle over here at negative pi over 2. It goes to the low point at negative pi over 4. It goes back to the middle, then to the high point at pi over 4, and then to the middle at pi over 2. So there's a reflection of a sine wave. Sometimes this thing just doesn't want to write. I just can't see it already. There we go. Okay, one more period. Pi over 2, the period is pi units. So pi over 2 plus another pi, the next one's going to end at 1.5 pi. Half pi to 1.5 pi is pi units. So then you're going to need your points. So that's pi over 4, 2 pi over 4. This would be 3 pi over 4. This would be pi. Wait, do I have my points? I have too many points. So this is pi over 2, 3 pi over 4. Yeah, I've got too many points. I need this one. Maybe. Why won't this erase? erase that. Okay, so then 3 pi over 4, this would be pi, and this would be 5 pi over 4. And this one doesn't exist. But again, I can't erase. There we go. Okay. So then we complete another sine wave. So it would go high, it would go low, middle, high, mid. Thanks. Okay, now I draw my asymptotes. Every time it hits the sinusoidal axis, you have an asymptote. So it's the sinusoidal axis at negative pi over 2, at 0, at pi over 2, here, 3 pi over 2. And then you reciprocate all of them. So they share the low point. So they share the low point. Maybe. Flip it over. I wish you guys could see what I'm doing. It's not working very well. There we go. Share the high point. Flip it over. Share the low point. Flip it over. Share the high point. Flip it over. You can extend it forever. And then again, if you want to erase your sine wave, you can. But for some reason, my eraser doesn't work very well. It's erasing anything I don't want it to erase. Yeah, but you get it. Okay, that's it. You have classwork to do. You're going to graph 4 of these in your classwork, and I hope you understand. If not, you can also read your textbook. Okay, have a great day.